The title of this exercise is Carbohydrate Fermentation, and we are looking to see which sugars does your bacteria have the ability to ferment. Okay, so number one, does your bacteria have the ability to ferment at all? Some bacteria are non-fermenters. Pseudomonas is an example of one of those. It does not ferment at all. And then there are other bacteria that are fermenters, but only have the ability to ferment certain kinds of sugars, depending on which enzymes they produce. So just because it's a fermenter doesn't mean it's going to be able to ferment all kinds of sugars. Now, the reason why we do this set of tests is to help us identify an unknown. So based on how many sugars it ferments or which sugars it ferments is going to give us more information about our bacteria to be able to try and identify an unknown. Now, there are lots of different sugars that you can test. If you Google carbohydrate fermentation, you're going to see that there are lots of sugars that you can test for fermentation. We are only testing 4. So we've got our 4 tubes here. And like I said, we're testing for fermentation in all of them, acidic fermentation. So does the bacteria take the sugar, ferment it, and produce acids? If acids are produced, the pH is going to drop. Now, let's talk about what's in the tubes. We've got 4 tubes here, so we have 4 different substrates, okay? Each tube has a different sugar in it. The 4 sugars that we're testing in here are lactose, glucose, sucrose, and mannitol. Now, we have 2 monosaccharides and 2 disaccharides. The 2 monosaccharides are glucose and mannitol. That means they are simple sugars. They're small, 3 to 7 carbons long, glucose being 6. Okay, mannitol is an alcohol sugar, so it has an alcohol group on there. Okay, that's why you have the OL at the end. So these are our 2 monosaccharides, and then these are our 2 disaccharides, lactose and sucrose. Lactose being made up of glucose and galactose, and sucrose being made up of glucose and fructose. So we've got our disaccharides and our monosaccharides. Now, you will notice that the tubes are red. That's not the sugar that's turning it red. It's the pH indicator. Again, we're testing for acids. If you're going to test for an acid or a basic product, an acidic or a basic product, you need a pH indicator. The pH indicator that we're using here is phenol red. Now, don't get that confused with methyl red. Methyl red is the reagent that is added in the methyl red test for the MVIX. This is phenol red. Phenol red has already been added to the tubes. It's already built into the media. So you don't add anything to these tubes. They're already red. That's because of the pH indicator that's in there. Now, there's also something else in that tube. I don't know if you can kind of see it. It's called a Durham tube. The Durham tube is there to catch gas. Some bacteria, when they ferment, will produce gas as a byproduct. Some do, some don't. So that's what the Durham tube is there for. As the bacteria grow inside of the tube, if they're fermenters and if they produce gas, as they ferment, the gas will be produced and will be caught inside of the Durham tube. The Durham tube is basically like a little mini test tube that's upside down inside of this tube. Okay? So that's what it's there for, is to catch the gas. So you inoculate each of these tubes with your bacteria, incubate them for 24 hours, bring them back, and then we're going to look at the color change. So now I'm going to inoculate these 4 tubes to show you the inoculation process. So again, just like the MVIX, I'm going to use my loop for this. Okay, now in your book, there's 4 different bacteria that are named in your book for this test: E. coli, Citrobacter frundi, Proteus vulgaris, and Pseudomonas aeruginosa. All of those are gram-negative organisms. I'm only going to do 1 because there's no need in me repeating this 4 different times, but that is what would be normally in your lab manual. So of course we want to use aseptic technique, so I'm going to use my Fireboy. I'm going to flame my loop. Want to make sure that we flame it really good. Now remember, if you remember the MVIX, I only flame my loop once, got my bacteria once, dip, 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 stabbed, and come across the top of the slant for the MVIX. That's because we're testing 4 different things. It doesn't matter if you mix the media or not because you're adding the reagents. Now, for this, however, our pH indicator is already in the tubes, and we have 4 different substrates that we're looking at. So we don't want to mix the sugars because you could get a false positive if you accidentally mix the sugars, okay? So I've got my loop flame. It's cool. I'm going to go in. Give me a little bit of bacteria. It doesn't take a lot. Dip, swirl. Flame my loop again. Make sure to burn off any of that media. Let it cool a little bit. Get my bacteria again. And I'm basically going to repeat this process for each tube. And last one is mannitol. Okay, so I inoculated my bacteria for my tubes. Now I'm going to go put them in the incubator. So let them incubate for 24 hours. When I come back to them, you will see that there's growth on the tubes. Now, I inoculated 2 different ones. I did E. coli and I did Pseudomonas. E. coli being the fermenter, Pseudomonas being the non-fermenter. That way you get to see what a positive result looks like and what a negative result looks like. So let's go over the results and what they look like. So here's my E. coli set of tubes. My Pseudomonas is in the back. I'll show you those in a minute. Okay, so for phenol red, under acidic conditions, phenol red turns yellow. So when the sugar is fermented, acids are produced, pH drops, phenol red turns yellow. Now, don't get that confused with the methyl red. Methyl red, remember, a positive result is red and a negative result is yellow. For carb fermentation, it's the opposite for phenol red. Phenol red turns yellow under acidic conditions for a positive result and stays red for a negative result, okay, where no acids were produced. So, here's my first tube, which is the lactose. You see that the tube is clearly yellow, so that's a positive result, and you see the gas bubble in the germ tube. So E. coli can ferment the lactose, and it produces a gas bubble whenever it ferments. So moving on to the glucose. You will see the glucose is clearly yellow, and there also is a gas bubble. So that's a positive result for carb. Now, sucrose is red. So that's a negative reaction. So what this means is that E. coli cannot ferment sucrose. It does not have the ability to ferment the sucrose. And lastly, my mannitol. There's my yellow again. There is a gas bubble in there. It's just hard to see because my mannitol is kind of below the threshold of the drum tube. So the pattern that E. coli has is positive, positive, negative, positive, with all the positives having gas bubbles. So giving us more information to be able to identify if this bacteria was E. coli or not. Now, if you look at the Pseudomonas, I told you Pseudomonas is a non-fermenter. So all my tubes are red. Now, the glucose tube looks a little orange. Okay, that's because the glucose tube starts out as orange. Okay, so if you look at the glucose tube here, this one hasn't been inoculated at all. And look how close it is to the original color. So that's a negative result. And if you look at a positive tube, you can clearly tell this is yellow. Okay. So my Pseudomonas, now you can still tell that there's growth there. There's cloudiness in the tube. So the Pseudomonas grew, but it is a non-fermenter. So it does not use the sugar for fermentation. It uses it for respiration because Pseudomonas is a strict aerobe. If you remember from our motility test, Pseudomonas is a strict aerobe. What that means is it doesn't have the ability to ferment. It's only going to be able to do respiration. But if you have any questions on anything, like I said, all of this information is in your lab manual somewhere. Please, while you're watching the video, if you want to read along, highlight, take notes, whatever works best for you.